We continue the introduction to time series data, part 3, now focused on the TS class in R. In this lesson, you will be introduced to the oldest class format for time series data in the software R, that is TS function. You will learn that the TS function requires time series without missing values and with all measurements recorded at the same frequency. You should have RStudio or R open to do the work that we are going to propose here. Why do we need to know that? All packages in R are based on base R software, and many programs are written in base R. By knowing the basic and oldest code in base R, you gain efficacy in creating your own code. The modeling and forecasting approach that you use in the future depends on the kind of data that you have. If you cannot determine the prominent features of your data before you analyze it, you will not know how to proceed. It is good to start by seeing what a TS object looks like. We can start by looking at some data sets that come with R, which are already TS objects. We look first at quarterly data, one observation per quarter. Quarterly data consists of data that has 4 observations in a year. We will start with the Johnson & Johnson data set, which is a time series. So in R, if you are in R, just type Johnson & Johnson. You will see that this is a data set that starts in the first quarter of 1960 and ends in the last quarter of 1980. The length of the Johnson & Johnson data, or the Johnson & Johnson time series, is 84. There are 84 observations. When you type class Johnson & Johnson, you will see that it is a TS object. That's good. That means that you can use all the code that R has embedded, base R has embedded in it to handle TS objects. One of these code functions is the start function. If you have a TS object, the start function will give you when the data starts. You should get 1960 quarter 1 if you type start Johnson & Johnson. If you type end Johnson & Johnson, you will get 1980 quarter 4 as the end date. The frequency of Johnson & Johnson is going to be 4. That means 4 observations per year. The length of Johnson & Johnson is going to be 84, as we said. If you type window Johnson & Johnson, start 1962, quarter 2, and quarter 3 of 1971 ending, then you will get this data set. This is a subset of the whole Johnson & Johnson time series. In this little subset, you can see that the window that we have chosen, the subset of data, starts in quarter 2 of 1962 and ends in quarter 3 of 1971. And then you want to find out whether there are any missing observations. That sum is in a Johnson & Johnson will tell you how many are there. You will not find any in this data set. That was a data set that is inside R. Now we wonder, how do we create a TS object using our own raw data that we are going to import into R? Well, we can do that. We use a very simple data set now to just focus on how to do it. Suppose the data are quarterly. It starts on the first quarter of 1910 and ends in the fourth quarter of 1912. This is the data. It's the data that I enter by hand. So it's just a vector of data. These are the observations, the measurements. And the first measurement is going to start in 1910, first quarter, and end in quarter 4 of 1912. So I call it Amber alerts. These are Amber alerts. And I make it a TS object by just saying that using the TS function and saying, I want a TS object for the data that I just enter, starting in quarter 1 of 1910 and quarter 4 of 1912 ending with frequency 4 so that we alert R to recognize that this is quarterly data. If you type class Amber, the new object you created that is now a TS object, it's going to tell you that it's TS. And then you can visualize the data Amber, and it will look like that. As you can see, R has converted the data that we enter by hand, which of course, when you are analyzing data, you will probably import the data from some source. But this example shows that R converts the data that we enter into a format that is understood by R as a TS object, and a format, therefore, for which we will be able to use all the functions that R has embedded, base R has embedded for the TS objects. So notice how neatly R organizes our data, 4 observations per year. Often we will first import the data and then clean it, and then we make it a TS. Here is a data set that has a lot of garbage in it, has commas, has lines that should not be there because these are aggregate. We want our data set to have 2 time series that are monthly, right? One for domestic, 1 time series for international passengers. Maybe we want also the total, but in this case, we're going to focus on just part of it, okay? So we start by reading a data set that we already cleaned a little bit. We removed outside these lines that have the total. And we look at the data, and of course, we study its information with the str function. But then we want to remove the commas before we analyze the data that we enter. Why? Because R doesn't understand commas. R thinks that if the comma is there, these time series are character, they're not numerical. And in order to do time series analysis, you need numerical data. Okay, so we use these R commands to remove the commas. So we're cleaning the data in some way before we can go on and analyze it. Okay, and before we make it TS. Okay, and then we're going to subset years 2012 to 2019. And we'll make it a time series object. Notice that we are doing it after we clean it. So we do TS of the data without the comma, and we tell R when the time starts. This is going to be month 2, February of 2002, and June of 2019, with frequency 12, because the data are monthly. You can see we have an observation for each month. Okay. So this is the data we enter, and then we subset it by using the window command. So sometimes you enter a big data set and all you want is to analyze subsets of it. The window statement will allow you to do that. And of course, you can do a time plot of a TS object and observe. In this case, we are plotting just the window that we extracted from the bigger data set. So what are the limitations of TS? Well, it has quite a few. If we have missing data, it's not going to work. And if we have very highly granular data, such as, for example, hourly or seconds data or minutes data recorded every minute, there is going to be some difficulties in telling R the frequency of this data, because the frequency of a time series is the number of observations per cycle. In TS, the cycle is a year. So TS understands how many observations per year. So for annual data, the frequency is 1. For monthly data, the frequency is 12 observations per year. If the data is quarterly, there are 4 observations per year. If it's weekly, we start having problems. Are there really 52 weeks per year? And then when we get to hourly or daily data, it will have even more problems. How many hours per year? How many days per year? It depends. Sometimes we have leap years. Do you understand how we are starting not to have things so clear anymore when we use TS once you pass the monthly frequency? So what do? Well, we use other features, other functions that will help us in that case. So ours has some limitations, and these are very important to remember. So note that using the frequency argument in TS function makes sense only if there are no missing values in the data and the sampling interval between the observations is the same for all. That is, if you have weekly data, it is one observation every week. If you have monthly data, one observation every month. If you have data such that you have an observation 1 week and then the next observation is 3 weeks later and the next observation is 2 weeks later, that's going to ruin the use of TS for your data formatting. So how to handle hourly or daily data while using TS then? If the frequency is larger than a week, for example, a day or an hour, and we think that there could be some regularity, a day of the week has lower values, that means daily seasonality or weekly seasonality, then we must forget the annual cycle of TS. So for example, in here, we have time series starting with the second quarter of 1959. That's okay, quarters are okay. Daily data where 1 day stands out, we think that there is 1 day of the week that stands out, okay? Then in that case, we might want to give frequency equals 7 and then start. Now what we have to tell R is to start in the 12th week, second day of that week, if that's the case, and put calendar equal true. If we have hourly data where 1 hour of the day we think stands out, for example, the rush hour, then we think, okay, we put TS, let's say we have 48 observations. We put a frequency of 24 for how many hours are in the day. And then we start in day 110, hour 6, calendar equal true. So notice how this is not so flexible anymore. And of course, when we plot, we are not going to see the nice plots anymore. We will not have the date expressed in the horizontal axis with the plot.ts. So I wanted you to have all these things in mind when you use TS. What we noticed then in this lesson is that the TS class in R allows us to analyze time series that do not have missing values and have all observations recorded at the same frequency. Some TS objects are already stored in R, but we can make a time series of our own, an object of class TS. And if dirty the data, we clean it first before we make it a time series object, a TS object. Time series recorded at higher frequencies than a month or that have more than one possible seasonality, like weekly data, pose problems if we want to work with the TS class in R. I hope you enjoyed this presentation and find it useful. Thank you for listening.